In the Ksp of calcium hydroxide lab, you are going to titrate a solution of saturated calcium hydroxide in order to determine what the Ksp of calcium hydroxide is. So your lab handout walks you through setting up your pH meter, and we've actually gone through that in a previous video. And then it walks you through what to do with the calcium hydroxide and setting up your lab class. So once you have all of that data, what are you going to do with it? So you will be able to determine from the titration curve on your lab class what the volume of hydrochloric acid was that you needed in order to get to the equivalence point. So question 1 under the data analysis tells you to calculate the hydroxide ion concentration from your titration results. So if we write out the reaction, we have calcium hydroxide plus hydrochloric acid gives us calcium chloride plus water. So now we need to balance this equation. So to balance this, what we're going to do is let's go ahead and make our list and balance this reaction. So we have 1 calcium, 2 oxygens. We actually have a total of 3 hydrogens and 1 chlorine. On this side, we have 1 calcium, 2 chlorines, 2 hydrogens, and only 1 oxygen. So we need to balance this reaction. So let's start by putting a 2 in front of HCl, and that's going to give me an even number of hydrogens, and it's also going to balance my chlorines. And then if I stick a 2 in front of the water, now I balance the hydrogen and the oxygen. So we needed a balanced reaction because we need to be able to balance this. So we then need to calculate how much of our hydroxide we have. Now we have 2 moles of hydroxide in this reaction, but we also have to keep in mind that when calcium hydroxide breaks apart into its ions, we get calcium plus 2 hydroxides. So we actually have 2 moles of hydroxide here. So in reality, we have 2 moles of hydrochloric acid to 2 moles of hydroxide ion, which really reduces to a 1-to-1 ratio. So, continuing data analysis for question 1, you're going to take whatever volume of your hydrochloric acid you used, and we know molarity is moles per liter, which means that we need to convert our milliliters to liters. And we're going to use a 0.05 molar solution of hydrochloric acid. So that's 0.05 moles of hydrochloric acid per liter. And then we've established we have a 1 mole of hydrochloric acid per 1 mole of hydroxide. So that will give you your moles of hydroxide. And then remember to calculate molarity, we need to do moles. You're going to take whatever moles you got in the last step and divide that by, you started with 15 milliliters of hydroxide, which is 0.015 liters. And that's going to give you your concentration of your hydroxide ion. So in step 2, you need to calculate the CaO2 positive concentration. So remember, the formula for calcium hydroxide is CaOH2. So for every 2 hydroxides, we have 1 calcium. So to get our calcium concentration, we're going to take what we calculate for our OH negative concentration and divide that in half. So finally, in number 3, and actually that's not finally because we still have a couple more steps, and I need to add a couple more slides here. Add a few more just to be on the safe side. So now that we have our calcium concentration and our hydroxide concentration, now in step 3, we can calculate Ksp. So we know that we would write our Ksp as CaO2 positive, and our hydroxide ion concentration is squared because there's 2 hydroxides for every 1 calcium. So that's going to give you your value of Ksp. In step 4, you're going to look up in your textbook what the accepted value for the Ksp of calcium hydroxide is. So there's a section in the back of your textbook that shows you accepted Ksp values. You're going to look that up in the back of your textbook, and then you're going to calculate your percent error. So percent error is your measured value minus your true value divided by your true value. So that is your data analysis for the calcium hydroxide lab. So make sure that you have submitted your purpose and procedure on Canvas, and I will see you in lab.